Hello there guys, I'm Dave, this is Will, and we're going to do the next presentation.
Here we go, so we're going to be talking about intrusive and extrusive volcanic features. So, intrusive volcanic features. Magma in intrusive volcanic features cools, crystallises and solidifies into igneous rocks. Slow cooling large crystals, e.g. granite and dolerite. After the overlying rocks have been eroded, the intrusive landforms, like this beauty, become visible.
We then move on to the dikes. The dikes are where magma solidifies in the vertical crack, forming groups called swarms. Dike material is more resistant than surrounding rock, leaving prominent features. However, it can also be less resistant, leaving depressions.
So here we go, you've got sills here. Magma solidifies into horizontal sheets between layers of pre-existing rocks, forming a low ridge.
We're then going to move on to looking at laccoliths and batholiths. And you can see here there's a laccolith and there's a batholith, and I'll just advance on that. You see, laccoliths form when viscous magma forces overlying rock to arch into a dome. Batholiths are much larger than the previous features. They often provide the magma for dikes, sills and laccoliths. Surrounding the batholith, extreme heat and pressure alters adjacent rock in a process called metamorphism, forming a metamorphic aureole.
So now, moving on to extrusive volcanic features, one of my favourites. So, magma in extrusive features cools, crystallises and then solidifies from surface lavas. Lava on the surface cools far quicker than magma underground. Cooling in the sea is even more rapid. Resulting igneous rocks tend to be finer grained with small crystals, for example this basalt.
Then we're going to talk about the material ejected from eruptions. There can be solid eruptions, or solid ejections, liquid or gas. The solid that spews out consists of ash, dust and glassy cinders. Blocks of material, for example remains of solidified lava, that block the vent of dormant volcanoes. The liquid that comes out come in the form of lava bombs made of tephra and pyroclast. They solidify in the mid-air. Tephra in its finest form is called lapilli. Liquid emissions include surface lavas, acidic or basic. Gas that's emitted is dominated by steam, but can also contain carbon monoxide, hydrogen sulfide, sulfur dioxide and chlorine.
These are all very dangerous. So now moving on to the types of lava. Oh no, hang on, that's a volcanic fissure. Just giving a few pictures here. Volcanic vent. And here's different types of volcano. Oh, hang on. I think I've gone a few too far. Hang on. Types of lava, you do this one, Dave.
Okay, well there's your basic. Does anyone know the silica content of basic lava? 50%, well done. Andesitic? 60. Rhyolitic? 70. Brilliant.
So, landforms from which magma emerges to form lava. If Jim wants to direct the camera at the... yeah, here's a fissure. Eruptions of basic lava, e.g. blocky RR or ropey pahoho, creates extensive lava. You've got a plateau, misspelt by Dave in this, which hollows an existing landscape, filled to create featureless basalt plains. And then you've got vents, which eruptions usually create cone-shaped landforms, which is the classic volcano image, with a summit crater.
Alright, then we move on to the classification of volcanoes. The basic shield volcanoes. These are formed from eruptions of runny lava, most common at mid-ocean ridges, rift valleys and hotspots. Acid dome volcanoes have thick rhyolitic lava associated with destructive plate margins. Eruptions are deadly explosive, with pyroclastic flows of incandescent gases, incandescent gases, ash and pumice called nuée ardente. Oh. The cone volcanoes form from alternating eruptions of ash, tephra and lava, building up the volcano in layers.
Can I just point out, we were kind of given duff information by our teacher in terms of the different... He said cone volcano, they're actually composite volcanoes.
You mean the cinder cone?
Oh no, those are cinder cones. But anyway, for the sake of argument, we'll just go with that. Calderas. Oh, no, hang on. Yeah, these are different types of volcanic eruptions. We didn't
We haven't got too much on this.
So
It's
yeah.
just
which of
there's
those
a couple
volcanic
of
eruptions
examples.
would be associated with shield volcanoes?
Well, you've got your Hawaiian eruption. You can see it's a very dome sort of structure.
The Icelandic eruption would also be
That's
a
a
shield
fissure
volcano.
volcano.
Yeah, but that's in contrast to something like the Pyrenean eruption, which is more of a cone volcano, your classic volcano image.
Mm. So then finally we've got calderas, which result from violent eruptions blowing off a volcano summit. This empties the magma chamber and allows sides of volcano to collapse inwards. Vast pit crater, up to many kilometres in diameter, is left to be flooded by the sea or fill as a lake. And, here's the 7 different types of volcanoes. There we go. So that explains. What are your 6, 7? No, yeah, no, you're right, there are only 6. But anyway, there you go. Cheers.
We love you, Dave! Did you spell Dave's name wrong?
Yeah.
Yeah. Okay, cut it.
Good morning, everybody, and welcome to our presentation on volcanoes. Okay. A few definitions to get us started. A volcano is a conical hill or mountain formed by material from the mantle being forced through an opening or vent in the Earth's crust. And volcanicity is a general term used to describe a range of volcanic activity often associated with a place or region, including volcanic eruptions, geysers and hot springs.
Right, so first up we've got hotspots. So first of all, radioactive decay of the Earth's core generates hot temperatures. If the decay is concentrated, then hotspots will form. The lower mantle is then heated, creating localised thermal currents where plumes of magma rise. These plumes of mafic lava then burn through the lithosphere to create shield volcanoes. Hotspots do not move with the plates above, so a chain of active and extinct volcanoes is created as the plate moves over the hotspot. So these are predictable Hawaiian eruptions which occur. Right, so next up we've got fissure volcanoes. So these occur at elongated splits in the Earth's crust at diverging constructive plate boundaries to allow mafic or basaltic lava to spill out. So mafic lava has a low viscosity due to 50% silica content. Therefore, gas can easily escape and pressure is not built up. The resulting Icelandic eruption is predictable, frequent and not very explosive.
Okay, now we have shield volcanoes. These are associated with mid-ocean ridges, rift valleys and hotspots where magma has direct access to the surface. They have runny lava and gently sloping sides. An example of this is the Hawaiian eruption, which we have here, which has basaltic magnetite. This is the Kilauea volcano in Hawaii, which is the #1 most active shield volcano in the world. Strombolian volcanic eruptions are also examples of shield volcanoes. Icelandic eruptions are also as a result of basaltic magma in this way.
Composite cones are your typical volcano that are formed from alternating eruptions of tephra, which is ash and lapilli, so material ejected by the volcano. And they create different layers of materials which result in the building up of the volcano over a long period of time. So as you can see, that layer of material would have been the most recent eruption. And they're also covered in many secondary cones with their own little layers of tephra, ash and lapilli. So we can see that this secondary cone would have erupted much more recently than the main vent over here by the different layers over here. They have antecedent lava, which is medium viscosity due to a 60% silica content. An example of a composite volcano. Usually composite volcanoes erupt with explosive eruptions such as Vesuvian eruptions. An example would obviously be Mount Vesuvius in Italy. They tend to occur.
Dome volcanoes, their lava is viscous and the volcanoes are often steep-sided. The rhyolitic lava cannot travel far and therefore often gets stuck in vents. This means that future eruptions are explosive and unpredictable. An example of a dome volcano is Mount Pelly in the Caribbean. Its infamous eruptions are deadly, explosive pyroclastic flows. This is an example of a Pelian eruption.
Supervolcanoes. Supervolcanoes occur when there is a massive hotspot, as Colin just said earlier, and when it builds up underneath the crust, and the crust can't take it anymore, and the crust kind of collapses, and lots of gas fizzes out, and many thousands of times more material than a normal volcanic eruption is erupted and expelled out of the volcano. They do not usually have mountainous appearances, as we can see here. They usually are seen as an indent on the Earth's crust, from where previous eruptions have occurred and the crust is sunk in a little bit. It's called a caldera. You can see the edge of the caldera just there. There's always a huge pool of magma underneath the caldera where the next eruption is waiting to happen. They're very infrequent. However, Yellowstone National Park in the USA is an example of a hotspot, and that's due to erupt imminently. The heat from the magma causes many geological features, such as thermal springs and geysers, which is where the lava superheats water which shoots out from underneath the ground.
Okay, here we have a table with the different types of lava and their different silica contents. We can see as the silica content rises,
Go look at the table.
the viscosity actually increases and the gas changes as we go through. So it goes from bubble through to difficult to get through to completely trapped. Also the different rocks change as well, so 50% is basalt, and then as we get more silica content, they are granite.
Right, so finally we've got another table which is showing the type of lava and where they would occur and on what boundary and eruption. So, yeah.
On the table. Take it to the table, please.
Alright then. So first off you've got mafic or basic lava. So that's going to have a lower 50% silica content, so therefore a very low viscosity. So gives you what kind of volcanoes they occur at, which is fissure or shield volcanoes, and then their eruption, and which boundaries they occur at, and how they are very predictable ones. So as you go down, intermediate lava is more explosive, it's got higher viscosity than basic lava, and tends to be a constructive, converging destructive plate boundaries. Then finally, there's a really explosive one, rhyolitic.
Cataclysmic.
Cataclysmic ones. So that's rhyolitic lava. So it's got 70% silica, very high viscosity. And they're supervolcanoes or dome volcanoes. And as Ben said before, they're Pelian eruptions or Pelian.
Thank you very much.
Roll your box.
Okay.